Yeah, so I remember now with that thing. I was struggling to try to remember something. I remember now what it was I wanted to say, and I think this isn't just in programming. This is a kind of a general rule in life, or to do with things that you sort of know when to say, um, when to turn something on or off, one way or the other. Say some kind of yes or no thing. You can turn the thing on, but for some reason or another, there's this asymmetry. It's very difficult to take, especially in programming, a flag like a Boolean value, usually anyway, that has that represents some large operation, like let's say balancing a database or something. Let's say you get this great big database, huge thing. How do I make it look big? Big database. So all this data in it, and you have a little function here that manages it, or that updates it. Update. Something like this. Now, a function like this, usually the first line you're going to see, actually give it a better name, balance. I don't know if you know what a balanced database is, or the idea of balancing, which is that all this data typically gets broken up into little pieces and sorted in like a tree kind of way. Now it's going to take me too long to draw a tree. Maybe I can produce one. There we go. There's a big tree. Okay, I'll put that into the database. Oops. I don't want that. What do I do? No, exactly. So here you've got this great big tree. And what balancing means is sometimes it gets lopsided. That is, you're trying to search for something, and for one reason or another, all of the things are piling up way over here. There's a little spot where it's full. I know one of these actually should go off pretty far to the right. And it's going to be to do with this eclipse thing. Fine. Anyway, the point is that when the tree is balanced, the lookups are very quick, only a few steps along. But when it's unbalanced, you have to. It's a long search because most of the data is down too far in the tree. But the operation of getting it back to being efficient again is also a slow process. So you're all constantly deciding, well, is it time to do the balance? When do we balance it? These things are not. You're not writing the whole thing all at once. Just every now and again, you want this to do this thing. So like here's our function. Balance. Here's our flag. So the first line you're going to see in a function like this will always be something like if it is balanced or something, return. Okay, and otherwise it'll go through the balancing act, and at the end is balanced equals true, and that will prevent it from coming back in here again. Now, how are you going to turn that back to false? At what point during the execution of the program, which is using this database all the time, but it's incremental. Who decides when to turn it back on again? Who decides when this thing is not balanced? The only way to find out really if it's not balanced is to actually go checking through it. But again, that's another slow operation. So you're in a bit of a bind with these kinds of booleans. And typically the answer is, okay, we'll decide that maybe once every day or every couple days or something, or a certain amount of time, and then there's a timer. And then there's going to be time since last update, and a whole string of booleans will come along. It always somehow ends up being a great big mess of flags that you're also trying to balance and keep track of. Once you do the update, you got to reset the timer to the proper value, and so on. It's a big hassle, always. And I had a problem with one of these types of booleans, and I didn't like the situation, and I didn't want to make more and more variables, so I invented this thing. It's this stupid thing, but it's actually quite useful. Because anyway, I have a physics background, so I was thinking of like the radiation and decay, things that decay. So I thought, well, what if I just had a boolean that decay? And I invented this thing called decaying bool. Decaying bool. And it looks exactly like a bool. It looks like a boolean variable. You declare it like that, and you can give it a time, some kind of time. But nobody sees this. As far as anybody's concerned, this is the interface. Nothing's changed. And so he sets it to true. And internally, eventually this thing on its own is going to decay back to false. I had a friend who went to the States. He was working on some telephone software, and this little class, or this object, was in his source code, and all the engineers there, they went like crazy over it. They loved the decaying tool. It was everywhere. They were all adding it to all their classes and everything. And it's kind of a silly aside, but anyway, that's the point though about this echo thing. Is that you can't they've turned on the carriage return, and there's no way to get it back off again. It could have been something you could add on. But this is bad. I did this. It's my fault. It should say this. I don't want to change it now because a lot of things expect it to be this. But see, if you want this, and you don't want this part, then there's a difficulty. You gotta try and clip that thing off. But that might not always be easy. But if it's not there, and it's not there, then it's very easy to put it on for whatever reasons you might want to add extra paths to this or something, right? But getting rid of it is not so easy.